Okay, so if you go to c++.com and I click on reference. Okay, are you guys seeing what I'm doing on the screen now?
Yeah.
Okay. And then containers over here. Here is a list of the different containers that the standard template library offers. And we, one way of looking at what we're going to be doing this semester is we're going to be going through most of these, talking about what they're used for, how to use them, and how to actually create our own version of all of these. That's probably like 80% of what we will be doing this semester. But here's a vector. So if I click on vector, I can look at everything I need to know about vectors, what the member functions are. A lot of these will be confusing if we don't know much about the STL yet, but you can see that the square brackets operator is defined. There's a function called @. There's a function called pushback, which is adds an element to the end of the vector. So a vector basically is an array, but with a lot of additional features. So, for example, now here's where things get complicated. I guess I should do this using Word so that I can make the font bigger and smaller. Okay, so stop share. Word share. Okay, so let's just play around with vectors a little bit. So when you declare a vector or any other standard template library class, you place the type of item that will be placed in the vector in angled brackets after the name of the class. So to declare a vector that will contain variables of type int, we would say vector, vector int. So there's the declaration of a vector. So one way of putting things in a vector is with the pushback function. So we might say vector1.pushback 47. This is, my setup here is really not ideal. Comment a little bit here. It's a little better. Okay, so that just adds the number 47 onto the back of, or I guess you could say at the end of the vector. Okay, capacity. The capacity of vectors change as they're being used. So you can set the capacity of a vector manually by using a function called resize. And then putting how big you want it in here. But if you add items using the pushback function, the vector will automatically change its capacity as needed. So for example, if I have a vector with 8 items in it and I call pushback and the capacity of the vector was 8, what's going to happen is the capacity, C++ is going to automatically increase the capacity of the vector. There's no rule in standard C++ for how it does that. So on some systems, you're going to see that in that case, it would simply double the size. So the vector would then have a capacity of 16 instead of 8 in my example. In some other systems, the formula is a little more complex than that. So what we're going to do is I'm going to actually run some code to demonstrate this. I haven't quite figured out how that's going to work yet, but hold on, give me a second here. All right, so sharing a different screen now. All right, you guys looking at the code now?
Yep, we can see it.
Okay. Mind recapping precisely what we would use vectors for. So good question. Basically, you would use a vector in a situation where if you know when to use an array, that's when you use a vector. And you probably, the only reason to use an array instead of using a vector would be if you're in a situation where you're really concerned about every billionth of a second in terms of how fast your code is going to run, because a vector is basically built on top of an array. So it's going to be slightly less efficient, but basically vectors are just arrays with more functionality, so and safer. So you probably use a vector instead of an array most of the time. Does that answer your question? Just realized that my chat is acting there. Sorry, I will get the hang of this. Will we stop using arrays in favor of vectors? It depends. We'll be using both. Sometimes we will be using arrays because we will be actually implementing some of these containers. A lot of what we're going to be doing in this class is sort of studying what's going on behind the scenes in these different container classes. And when we do that, we're going to be wanting to use the more primitive types like arrays. So we'll be using a mix, depending on what it is we're doing. All right, so here's some code. I am thinking that in an ideal world, this code would be bigger, but I don't think I have the ability to do that. So I'm hoping that you can manage with that. So if we run this, and this is probably not the environment that you are used to running programs in, but I have to go with it for today anyway. That's not what I meant. Okay, so here's the output of the program. Oh, you guys can't see that part, huh?
Nope.
All right, give me a second. Let me just share my screen. All right, so now you're seeing my whole desktop, right? Okay. All right, so you can see here, basically what we're doing is we're pushing one number at a time onto the back of the vector. And then we are printing the size of the vector, which means how many items are actually in the vector. And then we're printing the capacity of the vector. So when I just declare a vector, as soon as I push one item into it, the size is 1 and the capacity is 1. When I push the second item, the size and capacity both become 2. When I push the third item, the size becomes 3, the capacity becomes 4. So you can see here that when I need to increase the capacity of the vector, the capacity is being doubled. So when I have 8 items in my vector, the capacity is 8. When I go to push a 9th item onto the back of the vector, the capacity becomes 16. Okay. So basically the only things that we are using here, the only functions related to vectors that we're using pushback, we're using size, we're using capacity, and then down here you see we're using the function at when we print it out, and then I'm just doing the same exact thing again, printing the vector, contents of the vector a second time using the square brackets operator. Okay, so any questions about vectors? I know that was just like a super quick intro, but basically that's all you need to know to get started with them. And if you need to know more information, you can go back to c++.com, which, what did I just do? For example, you can see what how the constructor. So here are some examples of how you can declare vectors. You can provide, this gives it 4 ints, each with a value of 100. This is using the copy constructor. Anyway, and here's the description of the different constructors. So, all right. So I am. I'm gonna leave it at that with vectors for now. We will definitely be revisiting that. I want to talk quickly about something called size type. So let me. So you can, size type, basically each standard template library class includes a type named size type. And let me just say that the concept here is very simple. It can be a little bit confusing to try to understand why we're doing this. So my recommendation would be, if it doesn't really make sense at first, just kind of go with it, and no, you'll be fine. And I think as time goes along, it'll start to make sense. But basically, anytime you declare a variable that is going to be related to the size of the vector, instead of declaring that variable to be an int, which is what we did in the code we had up here a minute ago, we're going to declare it to be of type size type. There's a couple of reasons for that. And one is so that there won't be a type mismatch between us, the client, and the class we're using. For example, let's say that the size function in the vector class doesn't return an int. Let's say it returns an unsigned int, or let's say it returns a short, a variable of type short or long. There's no way for us, the client programmer, to know. So what one purpose of the size type is to make it so that there's a way for us to declare variables that are going to get that are going to match up with the type of the variable that's being returned by the class. The other reason for this is that on any given system, it's not guaranteed that a variable of type int or any other integer type will necessarily be big enough to represent the number of items in a container. So the size type provided by the standard template library classes is guaranteed to be able to do that. All right, so that's the rationale for size type, and we will be seeing more of that. You can see that I used it here because this is a variable that's representing the size of the vector. I used it here because this variable I is a variable that is going to get as big as the size of the vector, right? Okay, anyone want to ask a question about size type?
Were we supposed to be able to see what you were talking about?
You mean the code? What am I?
Yes, yeah. Did you have code on the screen?
I did have code on the screen. Am I not sharing it?
No, we see your lovely face though.
Okay. Well, that's unfortunate. There is, now you're looking at the code, right?
Oh, right, the old code. Okay, yeah, we did see this before.
Well, actually, this is almost exactly the same, but the original code had int right there. And I've replaced the int with the size type. Does that make sense? That sounds like a no.
Shouldn't there also be size type in that that other for loop? I don't know.
Which other? This one?
Yeah.
In this case, I'm just going from I is just going from 1 to 20. It's not really.
Yeah, I guess. Yeah, it doesn't matter.
The size of the vector. So, yeah, every class in the standard, every container class in the standard template library is going to have a size type. And so I could do this with vector. I could do this with list. I could do this with set. Whatever the STL class is, it's always going to have a size type. And so just to quickly go over what I did again, originally this said int, right, in the original code, int current size. I just replace it with size type because I know that the type of this variable is going to need to match up with the type that the class is using when it returns a value related to size. So anyway.
Doesn't that make line 14 like kind of redundant, or no?
No, it doesn't, because this is telling us, you mean this is actually
Oh, I see. That's you're declaring. Yeah, yeah. Okay. Thank you.
just declaring the
I
variable.
see.
Okay, so if no one has, I mean, I realize this may be a little fuzzy at this point, and we haven't done a lot of examples with it. So I think it's okay to just kind of put it out there, and we'll come back to it. Okay. Next thing we're going to talk about is iterators. So we're definitely just kind of all over the map here. The first section was introducing vectors. Second section is about size type. Third thing we're talking about is iterators. Iterators are actually a huge topic when you're using the standard template library. Basically, every container in the standard template library uses the same syntax for any time you want to iterate through every item in the container. So that may not, what's the word? The significance of that may not be obvious at this point, because we haven't really talked about a lot of data structures other than just an array or a vector. And with vectors, it's pretty easy to iterate through a vector, because you can use the square brackets operator and just use a for loop the way I did here in this code. With other containers in the standard template library, there's no way to access each element using the square brackets operator. So you need to have some way of being able to just say, okay, start at the beginning of the container, go to the next item in the container, go to the next item in the container, keep going until you get to the end of the container. Rather than have a different notation for each STL container, there's a common way of doing this. So I think I will just type, no, hold on a second. Time out. All right, so you're still seeing the code, right?
Yes.
Okay, so
Yes.
down here at the bottom, I've got two for loops. One of them is the original for loop that I used to print the contents of the vector. The second for loop is doing exactly the same thing, but I'm using iterators to do it instead of just using indexing to do it. And basically, one of the two assignments for this week is for you guys to do exactly the same thing. I'm going to give you some code that's written without using iterators, and you're going to translate it into code that uses iterators to do the same thing. And again, in case you're wondering, why would we ever want to do that? The point is that there are going to be other STL classes that we're going to look at where that's the only way to do it. Okay, so I'm gonna say that there are basically 5 steps to these for loops that we're gonna look at. We've got declare I. We've got initialize I to the beginning of the vector. We've got compare it to the end of the vector. Advance I to the next item in the vector. We've got access the item at position I in the vector. All right, does that make sense that those are basically the 5 things we're doing here? If you just look at this for loop, we have to have a way to do each of these 5 things using an iterator instead of using an int and indexing. So you can see, here's how you declare an iterator. Each STL class is going to have a type defined in the class called iterator. Actually pretty similar to the fact that each STL class has a type defined inside the class called size type, right? So that's not an uncommon construct. Move my mic away from the keyboard. Oh, because when I type, it makes a lot of noise, right? I can move my keyboard away from my mic. Actually, that's what I can do. I'm using an external keyboard on my laptop because the keyboard on my laptop is broken. All right, hopefully that'll be better. Okay, so there's how I declare I. Initialize I to the beginning of the vector. That's this part, right? In here we said I gets 0. Here we say I gets print me dot begin. So every STL class is going to have a member function called begin that returns an iterator that pointing to the first item in the class, in the container. All right, step 3, compare it to the end of the vector. So here we say, as long as I is less than print me dot size, okay, as long as I is less than the size of the vector, we could actually just as easily say not equal to here, right? That would also work. So that's sort of what we're doing here. We're just saying as long as I is not equal to the end of the container. So just like every STL class has a member function named begin, every STL class has a member function named end. Now, one thing that's a little surprising sometimes the first time you see this, but actually makes a lot of sense, is that the end function does not return an iterator pointing at the last item in the container. It returns an iterator pointing to one past the last item in the container. Make sense? No? Questions? No one surprised? Makes perfect sense. So let me explain it by giving the rationale for it. So here in this for loop, when we say I less than whatever the size of the vector is, what we're doing is we're saying, size is actually, so if the size of the vector is say 12, I is going to go from 0, the indexes of the vector are going from 0 up through 11, right? So what we're really doing here is we're saying, while I is not equal to the index that is 1 past the last index in the vector. Did that make sense? So it's very interesting for me to do this and not be able to look into your faces and see whether there's, you know, confused looks or or eyes glazing over or whatever. But let's say that, let's just go with 12 here. Let's say that there are 12 items in our vector, and the indices of those 12 items are 0 through 11. So I don't put 11 here, right? I don't say I less than 11, because then the item at index sub 11 wouldn't get printed. I say 12 here because, and 12 is the index of the next item in the vector after the last item in the vector, because 11 is the index of the last item in the vector. So that's analogous to what's happening here. The end function actually returns an iterator that conceptually, anyway, points to one past the last item in the container. And that makes it so that I is going to be an iterator pointing at the first item, and then the second item, and then the third item, and then the last item. And then when we move it past the last item, that's when we stop. Okay, so hopefully that makes sense. If not, feel free to start up a discussion about it in the discussion of this week. Okay, so that was the third thing, compare it to the end of the vector. Fourth step was advance I to the next item in the vector. So the ++ operator is overloaded so that it works with variables of type iterator. And it moves it to the next item in the vector. Okay, so just to be clear, this is not, I is not an int, right? I is an iterator. So the fact that we can use the ++ operator on it isn't automatic. It's news, right? I'm telling you, even though it's not an int, you can the ++ operator has been overloaded so that you can use you can use it on an iterator. And then finally, the way that we access the item that the iterator is pointing at is with the dereference operator, as if it was a pointer. So, which it's not a pointer, it's an iterator, but the star operator has been overloaded so that it acts similarly to how the star operator works on pointers. All right, so what you need to get, the bottom line out of all of this is that you would need to be able to reproduce this sort of thing on your own. Hopefully you'll be able to do that. And this is also all in the notes. Okay, one more thing about iterators. Wait, hold on a sec. I have the PDF if you'd like to. Yes, you will. Someone asked me this privately, but I'm going to answer it publicly. Yes, you'll have access to the recorded lecture. If I believe that you can just click on it used to be Confer Zoom and now it's something else. You can just click on that link and there'll be a list of recordings that, and you can go find it. Okay, so I'm going to get some new code up here. So here's the code. Here's the program we just had using iterators to print out the contents of the vector instead of just using indexing. Okay, any questions before I go on to the next thing? So fourth item, so let's see, what did we do? We introduced the vector class, we talked about size type, we talked about iterators. The fourth thing I want to talk about is const iterators. There's something about this function here, about the parameter here, that should make you uncomfortable. Anybody know right away what it is I'm talking about? It's right. It's not const, and it should be, right? That's, we are using pass by reference, which is what we want to do because we're passing an object, right? But because that object is not changing in this function, we want to make it const. Oops. Okay. So let me change it up here too. And let's see what happens when we run this now. And I know you can't see this, hold on. Okay, so now you can see my console window too, right? Oh, we got some errors. No viable conversion from something ugly to something else ugly. Here's what's going on. Now I'm trying to say print me.begin, assign that to I, which is of type iterator. The problem with that is that because print me is a const, the begin function doesn't return an iterator. It returns something called a const iterator. So in order to make this work, I'm going to have to, instead of making I be something of type iterator, I'm going to have to make it be of type const iterator. And then hopefully I think we'll be good again. Yes, now we're back to being good again. Okay. All right. I think that's all I want to say about const iterators. So there's a lot to learn about iterators. There are things like forward iterators and backward iterators, bidirectional iterators. We are just going to kind of stick with what we have here. Basically, the only the main difference between the different types of iterators is that they come with different operators that you can use with them. So we're just going to go with the ones that I've shown you here. The only other one is that you can use equal to, you can use not equal to. So basically, if you've got the operators that I've shown you right here, that's all you're going to need to know at this point anyway, in terms of your iterators. Couldn't, but you just const cast the basic iterator, shouldn't be using cbegin cend. That's a good question. I'm not sure. I know that the begin function, if it's called on a const vector, returns a const iterator already. To be honest, I haven't ever used cbegin or cn, so I would have to do a little research on that. Okay, we've got I've been asked a question privately in the chat. Probably would be better to ask it publicly. So the question is, are there any advantages in terms of memory usage for iterators versus a pointer to that element? And the answer is actually no, the opposite. Iterators are, they're an abstraction. They're built on top of either, depending on the container, maybe a pointer or maybe an int. So it's going to be less efficient than just using a pointer or an int. The point, though, is that these, with other STL classes that we're going to be studying, we don't have any choice. The only way that we have, we can't point directly at items in the container because we don't have access to that, right? It's an object with encapsulation and all that. So the only way to iterate through the contents of some containers is with an iterator that's provided by the class. Make sense? Hope that makes sense. Okay. Give me a second here. Okay, so moving on to the next completely random topic. And this is, so we're going to be talking about how to create our own templates. So going back to the code again, we're going to talk about how we could write our own, say, vector class and make it so that when we wanted to declare a variable of type vector, we would put the type of element in the angle brackets after it, just the way we did here. I'm going to start with, time out for a sec here. I know we have just about 10 minutes. I think I can probably get a pretty good start on this topic here, so that we'll have time to finish up on Thursday. All right. So, oops, I'm not sharing, huh?
You are, we can see it.
So here's a program that basically just sorts a list of integers, right? Here I'm going to fill up a list, fill up an array with a bunch of random numbers, 25 numbers. Then I'm going to sort them, and then I'm going to print them out. Here's my sorting function, and my sorting function calls this index the smallest function. So what I want to do here, so the topic here is template functions. I want to create a function that can accept, that can sort an array of any, that contains any type of element instead of only being able to accept arrays of ints. So the way we do that is actually pretty simple. Just above the sort function, I'm going to write template class T. And then in the parameter list, instead of saying int here, I'm going to say T. So what's going to happen is that the compiler is going to see that this is a template. And so it's going to just whatever type of array is passed in, it's going to know that that's T. Now in this particular function, it's not very interesting because we don't actually use that type any place else in the function. But we're also going to have to do that down here, right? Because this is going to have to be T. Oops. Whoa, what did I just do? Oh. Okay, and then I'm also going to have to do the same thing up here on the prototypes. Any questions about what's going on there? So now I can, hold on, I guess I'm gonna just have to live with sharing my whole desktop because I go back and forth way too much. Oops, what did I do?
The prototypes still don't have T as the type of the lists.
Oh, thank you. So let me try that. Static cast. Oh, you know, I should have run, I didn't even run my original program to make sure it was error free. So that I just discovered that there's actually an error in the notes that I just fixed. There we go. So that works just fine. And then if I want to, you can see here that what I've done in this code is I have done the same thing with the ints that I did originally. And then just to demonstrate that the sort function can also take an array of strings as a parameter, I've done the same thing with strings. Okay. So that's actually, you know, it's kind of cool. But where the real win is going to be is when we use templated classes as opposed to just a templated function. So basically where we're gonna start on Thursday when we talk is we're gonna talk about how to create a templated class. And then we just need to talk a little bit about exception handling and we'll be done with the content for this week. Anything else you want to talk about before we sign off? Hopefully I will get my act together a little bit and be able to do this better next time. Although I'm not quite sure how that's going to happen, but I'll work on it. Okay. If there are no further questions or comments, I will see you guys on Thursday.
Sounds good. Thank you so much. See you on Thursday.
All right.
Thank you. Bye-bye.
Thank you.
Everyone.